Imagine waking up at 4 a.m. The temperature outside your cabin has plummeted to a bone-chilling minus 40 degrees. The temperature outside your cabin has plummeted to a bone-chilling minus 40 degrees. Heating this entire space for the past 24 hours costs you less than the price of a cheap cup of gas station coffee. But instead, your room is a comfortable, warm 70 degrees. The craziest part? Most people living in the extreme north are trapped. They are completely at the mercy of massive, predatory utility companies. Men are literally forced to choose between buying groceries or filling up their heating oil tanks just to survive the winter. Standard home heating bills in these frozen landscapes routinely top $1,000 a month. If you rely on traditional electric baseboards or massive propane tanks, a single bad winter storm can completely drain your savings account. But a handful of clever off-grid builders and resourceful homesteaders have quietly abandoned the traditional energy grid. They are using an incredibly cheap, highly efficient mechanical loophole to slash their heating bills by a staggering 70%. Take a close look at the image on your screen. Specifically WhatsApp image May 30th, 2026 at 16.03.11_.jpg. It looks like an impossible, high-tech engineering fantasy. The graphic reveals a modern, minimalist cabin completely exposed to a vast, frozen mountain range. But inside the cutaway, you can see a mesmerizing web of brilliant orange heat waves flowing effortlessly through the walls and flooring. An arrow points directly at this setup, boldly labeling it as free heat. At first glance, you might assume this is just another piece of deceptive internet clickbait. You might think it is a fake concept designed by someone who has never actually spent a single day chopping wood or surviving a real northern blizzard. But the raw science behind this specific configuration is completely real. It is a brilliant combination of basic physics, smart space management, and a highly disruptive piece of hardware known globally as the Chinese diesel heater. Look back at the small, unassuming silver box nestled at the very bottom of the cabin structure in WhatsApp image May 30th, 2026 at 16.03.11_2.jpg. That compact unit is the entire heart of the operation. For decades, massive German engineering firms dominated the off-grid heating market. If you want a reliable, compact diesel parking heater for a custom camper van or a remote survival cabin, you had to shell out well over $1,500 for a premium brand like Webasto or Spar. For the average working man trying to build a self-sustaining life, that entry price was a massive barrier. Then everything changed. No-name manufacturing plants began flooding the global market with generic, budget-friendly versions of these identical heaters. Brands like Vever and Calorie started selling complete heating kits directly to consumers for anywhere between $100 and $200. The internet was immediately skeptical. How can a mechanical tool that costs 10 times less than the industry standard actually keep a man alive in the middle of a brutal sub-zero winter? Many critics assumed these cheap units would simply stop working, fail catastrophically, or burn out within a single week of continuous operation. But they were entirely wrong. These budget diesel heaters have become the ultimate underground tool for off-grid survival. They are rugged, incredibly simple to repair, and wildly efficient. But we need to address the elephant in the room before we go any further. A single small diesel heater will not magically heat a massive, uninsulated 4-bedroom suburban mansion for pennies. Anyone who tells you otherwise is lying to you. If you simply drop one of these units into a giant, drafty house and expect your massive utility bill to drop by 70% overnight, you are going to be deeply disappointed. The real magic happens when you understand the highly strategic concept of zone heating. Think about how the average modern house is heated. The central furnace kicks on, burning massive amounts of expensive fuel to heat hallways, empty guest bedrooms, storage closets, and high ceilings that nobody is currently using. It is a massive, incredibly wasteful misuse of energy. Smart Alaskans do things completely differently. They use these ultra-cheap diesel units to target the exact spaces where they actually live and work. By using a compact heater to warm an off-grid cabin, a detached workshop, a backyard greenhouse, or just the main living area of a larger home, you can completely turn down your main, fuel-guzzling furnace. You are only burning fuel precisely where your feet are planted. That is how you unlock the legendary 70% drop in your monthly heating expenses. To truly understand why this system is so radically superior to traditional portable options, you have to look past the shiny metal casing and understand the internal engineering. Let us break down the exact mechanical cross-section illustrated in WhatsApp image May 30th, 2026 at 16.03.11_2 JPG. Many people who need quick, emergency heat in a cabin or garage instinctively reach for a standard portable propane heater. It seems convenient, but it is actually a recipe for disaster in a cold climate. When propane burns, it produces a massive amount of moisture as a direct byproduct of combustion. If you run a propane heater inside a sealed, freezing room, all that hidden moisture immediately condenses on your cold walls and windows. Within days, your space is covered in thick frost, dripping water, and dangerous, toxic black mold. Even worse, unvented propane heaters slowly consume the oxygen inside the room, putting you at constant risk of asphyxiation. The diesel heater completely eliminates this dangerous flaw through a highly elegant, beautifully isolated dual-chamber design. Inside the aluminum body of the heater lies a completely sealed, heavy-duty cast metal combustion chamber. The system utilizes a small, internal 12-volt fuel pump to pulse tiny droplets of fuel onto a glowing ceramic plug. This fuel immediately ignites inside the closed chamber. At the exact same time, a specialized intake fan draws in fresh air from outside the building to feed that internal flame. The toxic exhaust fumes, dangerous carbon monoxide gases, and all the combustion moisture are then forced out through a separate stainless steel exhaust pipe that vents directly out to the floor or the wall. Not a single molecule of combustion gas ever enters your living space. So, how does the actual room get warm? This is the brilliant engineering trick shown by the glowing orange lines in WhatsApp image May 30th, 2026 at 16.03.11_2 JPG. A secondary, completely isolated internal fan draws cold air right out of your room. It forces this cold air directly over the exterior ridges of the superheated metal combustion chamber. As the air passes over the scorching hot metal fins, it absorbs the intense thermal energy without ever coming into contact with the actual fire or the burning fuel. The heater then blasts this air back into your living space as 100% clean, bone-dry, scorching hot air. The air coming out of the main nozzle regularly reaches temperatures as high as 70 degrees Celsius, which is over 150 degrees Fahrenheit. It acts like a massive, industrial-strength hairdryer that constantly circulates dry, comfortable heat through your space, instantly vaporizing any lingering dampness or window condensation. But there's a hidden reason why seasoned northern woodsmen swear by these specific units, a secret trick that you will never find printed in any official factory instruction manual. While these devices are universally marketed and labeled as diesel heaters, the smartest operators in the most unforgiving climates rarely run them on standard automotive diesel fuel during the dead of winter. If you travel to the gas station in the middle of a deep freeze and fill up a plastic jerrycan with standard pump diesel, you are taking a massive gamble. Regular diesel fuel contains naturally occurring paraffin wax. When the temperature drops below freezing, that wax begins to crystallize. If the temperature plummets toward minus 40, the entire bucket of fuel undergoes a chemical transition known as gelling. It transforms from a clear, free-flowing liquid into a thick, cloudy, unusable sludge. The moment that gel fuel hits the incredibly tiny, microscopic fuel filter and thin fuel lines of your compact heater, the entire system instantly clogs. The fuel pump locks up, the heater throws an error code on the digital screen, and the unit shuts down completely, leaving you freezing in the dark. To solve this fatal flaw, experienced northern residents bypass the diesel pump entirely. They fill their fuel tanks with pure kerosene or standard number 1 home heating oil instead. Kerosene possesses a radically lower freezing point than standard automotive diesel. It can easily withstand extreme sub-zero temperatures without showing even the slightest hint of gelling or thickening. But the benefits go far beyond basic freeze protection. Kerosene is a highly refined, incredibly pure fuel. When it burns inside the tiny combustion chamber of a cheap diesel heater, it creates a much hotter, significantly cleaner flame. Standard diesel fuel often leaves behind a thick, heavy layer of black carbon soot inside the glow plug chamber over hundreds of hours of continuous use. This heavy carbon buildup eventually suffocates the heater, causing it to smoke heavily, misfire, and fail prematurely. By feeding the unit clean kerosene, you practically eliminate this internal carbon fouling. The internal components remain pristine, the heat output stays incredibly high, and the operational lifespan of a cheap $100 heater is instantly extended by years. When you break down the raw operational math, the financial savings of the setup become absolutely undeniable. Let us look at the actual consumption numbers. When one of these cheap diesel units is dialed down to its lowest, most efficient operational setting, it consumes an incredibly minuscule amount of fuel. We are talking about roughly 0.1 to 0.15 liters of fuel per hour. To put that into perspective, a standard, easily transportable 5-gallon fuel jug holds roughly 19 liters of fuel. If you run your heater continuously on its low setting, that single, inexpensive 5-gallon jug will keep your space perfectly warm for up to 130 hours. That is over 5 full days of continuous, uninterrupted, reliable heat from a single fuel container. You can comfortably survive an entire week of a brutal power outage on a fraction of the fuel a standard home generator would consume in a single afternoon. If you are ready to stop wasting money and build one of these highly efficient systems for yourself, you need to understand the exact step-by-step DIY installation blueprint to ensure you do it safely and correctly. The first major hurdle you must tackle is the electrical power source. Even though these are fuel-burning heaters, they are fundamentally electronic devices. They require a steady, reliable 12-volt direct current power supply to run the internal computer motherboard, drive the fuel pump, spin the dual-axis fans, and heat up the power-hungry ceramic glow plug during the initial startup phase. You cannot simply plug this unit directly into a standard 120-volt wall outlet. If you want to run it inside a garage or a workshop that has standard grid power, you must purchase a dedicated AC to DC power converter. This handy tool takes the high-voltage electricity from your wall and steps it down safely to a stable 12-volt current. But if your ultimate goal is true off-grid independence, the gold standard setup is to connect the heater directly to a high-capacity deep-cycle marine battery or a modern lithium iron phosphate battery pack. During the first 2 minutes of the startup sequence, the heater requires a significant electrical surge of about 10 to 15 amps. This power is used to get the internal glow plug glowing red hot to ignite the incoming fuel. Once the flame is fully established and burning self-sufficiently, the glow plug turns off completely. At that point, the electrical draw drops down to a tiny, negligible 1 to 2 amps just to keep the internal circulation fan spinning. You can easily sustain this tiny electrical draw indefinitely by pairing your 12-volt battery with a single, inexpensive 100-watt solar panel mounted on your roof. You create a completely closed-loop, self-sustaining heating ecosystem that requires absolutely zero connection to the commercial electrical grid. Now, let us analyze the highly unusual dual-chamber glass wall architectural layout displayed in WhatsApp image May 30th, 2026 at 16.03.11_2.jpg. Notice how the diesel heater is strategically placed inside its own distinct lower external compartment, completely separated from the primary living room. The hot air is then channeled upward through a specialized glass-faced thermal channel. This design addresses two of the biggest complaints associated with running budget diesel heaters: mechanical noise and aesthetic clutter. While these units are incredibly efficient, they are certainly not silent. The small fuel pump operates via a rapid mechanical pulsing action that creates a distinct, rhythmic clicking sound often described as a mini jackhammer. Additionally, the high-speed air circulation fan emits a constant, low-frequency whirring noise when running at maximum capacity. If you mount the entire unit directly inside a small, quiet bedroom right next to your bed, that constant clicking and fan noise can easily keep a light sleeper awake all night. By utilizing the clever design logic shown in WhatsApp image May 30th, 2026 at 16.03.11_jpg, innovative off-grid builders completely isolate the mechanical noise outside the living envelope. They construct a sealed, weatherproof exterior utility box or an integrated double-wall glass vestibule to house the physical heater and its fuel tank. The noisy fuel pump and the main mechanical body remain completely outside. Heavy-duty, highly insulated ducting pipes then channel the pure, dry, hot air straight to the wall into the interior living space. This layout can also be beautifully integrated into a classic Tron wall system. A trombe wall is a massive, dark-colored, heat-absorbing wall covered by an exterior layer of glass. During the peak daylight hours, the sun beats down through the glass, rapidly heating up the trapped air in the massive wall behind it. By venting your diesel heater directly into this glass-enclosed air channel, you create a powerful hybrid heating system. The diesel heater provides instant forced hot air circulation whenever you need it, while the surrounding glass structure acts as a passive solar collector that retains and radiates that thermal energy long after the heater has been turned off. However, building a highly efficient DIY heating system means you must respect the laws of thermodynamics and chemistry. If you treat a cheap diesel heater with carelessness, it can quickly become an incredibly dangerous liability. Because these units are sold online at such low price points, the quality control during mass production can occasionally be imperfect. You must take your safety completely into your own hands. The absolute most important non-negotiable rule of operating any diesel heater is the immediate installation of a high-quality, dedicated carbon monoxide detector inside your living space. Carbon monoxide is a terrifying, completely silent killer. It is entirely invisible. It has absolutely no odor and can fill a sealed room in a matter of minutes if an exhaust pipe ever cracks or leaks. You must mount the detector close to the floor near your sleeping area. Before you ever ignite the heater for the very first time inside your cabin, you must visually inspect every single centimeter of the stainless steel exhaust pipe. Ensure that the exhaust joints are completely sealed with high-temperature silicone or heavy-duty exhaust wrap, and verify that the exhaust tip vents far away from any open windows or fresh air intake vents. The second critical safety protocol is the outdoor burn-in process. When these units are manufactured in the factory, the internal metal stampings, aluminum casings, and plastic shrouds are routinely coated in a thin layer of protective machine oils, manufacturing lubricants and chemical residues. If you install a brand new unit straight out of the box directly into your home and turn it on, these oils will immediately begin to cook and vaporize. The heater will emit a thick, acrid, incredibly toxic chemical plastic smell that can cause severe headaches, dizziness, and throat irritation. To avoid this, always set up your new heater outdoors on a temporary test bench or concrete driveway for its very first operational run. Connect it to a temporary battery. Fill the tank and let the unit run on its absolute highest heat setting for at least 1 to 2 full hours out in the open air. This allows all the factory chemical coatings to completely burn off and dissipate safely outdoors. Once the unit stops smelling completely and burns entirely clean, it is finally ready for a permanent indoor installation. The third and most frequently ignored safety rule involves the strict shutdown sequence of the machine. This is the single biggest reason why amateur users completely destroy their heaters within the first few weeks of ownership. Imagine you are done using your workshop for the day. The heater is blasting out intense heat on its maximum setting. You want to leave, so you walk over the battery and simply yank the main power wire straight off the terminals to turn it off instantly. This is a catastrophic mistake. When the heater is running at full capacity, the internal combustion chamber is reaching scorching temperatures of several hundred degrees. The only thing keeping the surrounding plastic casing and delicate electronic circuit boards from melting is the constant, high-speed airflow provided by the internal fan. When you suddenly yank the power cord, you instantly kill the fan while a massive, roaring thermal energy reserve is still trapped inside the metal core. Without the cooling airflow, that intense, bottled-up heat immediately radiates outward into the rest of the machine. Within seconds, the heavy plastic outer shroud will warp and melt, the delicate wiring harnesses will singe, and the main electronic motherboard will be permanently fried. To prevent this self-destruction, you must always use the official power button on the digital LCD controller to turn the unit off. When you press the off button, the internal computer immediately cuts off the fuel supply to stop the fire, but it keeps the electric fan running at high speed for an additional 5 to 10 minutes. The fan will continue to spin continuously until the internal sensors confirm that the metal combustion chamber has cooled down to a safe, stable temperature. Only after the machine has gone completely silent on its own can you safely disconnect the main power source. When you strip away all the sensational clickbait formatting and flashy graphics from modern online media, you find a powerful truth. True self-reliance and smart homesteading aren't about having a massive bank account or buying the most expensive commercial systems available. True innovation is about taking rugged, highly efficient commercial technology, originally engineered to keep long-haul semi-truck drivers warm in their sleeper cabs during cross-country winter routes, and intelligently adapting it to heat your own home, workspace, or survival cabin for literal pennies on the dollar. By mastering the simple science of clean combustion, choosing the right non-gelling fuels, and respecting basic operational safety rules, any resourceful man can completely break free from the crushing grip of expensive utility companies and stay warm to the most brutal winters imaginable.